today on day 2, we're actually going to be practicing what is called slope, which is actually the same exact thing as what you learned yesterday when we were talking about constant rate of change. It's just that in 8th grade, they give it a new name. So if we look here, it tells you what slope is. So slope is just the steepness of a line, okay? So whenever you're really steep, that means you're really close. Your line is really close to being vertical. So like, for instance, this pencil. But if you're not steep, then that means you're really close to being flat. It can be positive, negative, undefined, or zero. You can find it in many ways, such as graphs, tables, equations, and then also we're going to figure out what kind of slopes, what they look like as far as our positive, negative, undefined, or zero, okay? And then over here on this side, we're going to actually circle the positive slopes, box the negative slopes. So let's go ahead and deal with the graph section first. So we have to solve exactly how we solved for constant rate of change with the whole rise over run. So it's the same exact information. It's the same exact method that we used yesterday. There's nothing different. It's just a different name for it. That is literally it, okay? So first off, if we're looking at this line and we look at it from left to right, just like we were reading a book, what does it look like is happening here? Is a line going up or is a line going down? So if you look at it from left to right, the line is going down. So that means that this is going to have to be a negative slope. So I'm just going to put a little negative sign right out here. That way we don't have to worry about whether we have a negative or positive move. We already know that it's supposed to be negative. All right, so then after that, all right, just like we did yesterday, we have to make sure we find 2 points if they haven't found 2 points already, which they did. One up here, one down here. And then we have to make sure that we bunny hop and figure out how we rose. So in other words, how we went up or down. Put that on top because Y's always have to go on top. And then how we have to run, which is left or right, which is our X's. All right. So let's look here. So if we're focused on our rise first, then which direction do we have to go, up or down, to get to this next point? We've got to go down. So let's see by how much. So if we look at these increments really quick, it's really important that we look at these increments because if you can tell, they say that basically 2 boxes together equals one whole jump. Okay, so that means that each box really just means 0.5, correct? So let's make sure we're thinking about that whenever we're making our jumps, okay? So here we go. So 1 jump is 0.5, 2 jumps is 1, 2.5. I'm sorry, I counted wrong. Okay, so 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, and it looks like we got to stop there. All right, so we know that this was a total of 5 all together, correct? All right, so then for our little section that says rise, we can put that 5 there. All right, now for our run. So keep in mind, once again, each box is worth 0.5 is what we said. So 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4. So you've got 4 for your run. All right. And then whenever we turn this into a decimal, whenever you put this into the calculator, what do you wind up getting? So let's go ahead and figure it out. So here's my calculator, and I'm going to put a negative out here, and then 5 divided by 4. I just get negative 1.25. So that's our answer right here. All right, so that was with the graph. Oh, and I forgot to put that number right there. Okay, so that was with the graphs. Now with the tables, it's just same old stuff. So as far as our x's, what did it take to get from 0 to 5? Hopefully we know that's just plus 5. What about 5 to 10? That's just plus 5 again. All right, now let's see about the y's. So what did it take to get from 20 to 40? Add 20. What about from 40 to 60? Add 20. So the fact that all these numbers are the same means this is good. This is actually our constant rate, or in other words, our slope, okay? So we're gonna put the change in y over the change in x and then simplify, AKA divide. All right, so my change in y was 20. And since I said plus 20, we're just gonna consider it as a positive 20. And then down here, up here, sorry, as far as our x's, those were plus 5, so we're gonna consider those as positive 5s. So whenever we go to put that into the calculator and divide, is 20 divided by 5. So 4 is your answer. That is your slope. All right, so now equations. Equations, if they ever ask you what is your slope as far as an equation, it's really easy. You see this little arrow right here that's pointing towards the m? That m, whatever that number is always going to be your slope. And then you see this little arrow right here that's pointing towards the b? That's always going to be your y-intercept. And we will learn about that. No worries. Okay, so here's an example. What is the slope here? Go ahead and circle which number is considered the slope. Hopefully, just by looking at this little example here, we know that our slope number is going to actually be just 6. So no x on it, no nothing, just 6. Okay, and then here are our types of slopes. So like we mentioned up here, they can be positive, negative, undefined, or 0. Okay, so if we look here, as far as our positives and negatives, y'all are pretty good at kind of figuring those out. So with the whole looking left to right rule, as far as this top one right here, if we look from left to right, what's happening to your line? It's going down, so it's going to have to be a negative. Okay, so we're going to say right up here, negative. Okay, and then up here, if we look from left to right, what's happening to your figure? Looks like it's going up, so that one's going to be a positive. All right, now these two we probably are kind of unfamiliar with, which is fine. All right, this one right here, anytime you see a line like this that's just going horizontally straight and that's it, there's no sort of angle to it whatsoever, this is going to mean that your slope is automatically a 0, okay? That means it has no slope whatsoever. It's just a flat line. So that's going to be 0. And then right here, on this one, where if you have a vertical line ever, okay, then that means this vertical line is going to always mean undefined, okay? The reason why this one has the name undefined is because in order to be a line that is linear and has a slope and all that stuff, you have to be able to cross this y-axis. So if you look at all these other ones, boom, that crosses the y-axis, boom, that one crosses the y-axis, boom, so does that one. But this one's the only one that doesn't. So that's why it can't get its own number. It has to just get the word undefined. Oops. Okay, undefined. So last portion on this slide says we have to circle the positive slopes and then box the negative slopes. So go ahead, make sure you circle the positives and box the negatives, and I'm going to pause the video. Okay, so hopefully on this first one right here, since this is a positive slope, if you look from left to right, we circled it. All right, on this one, that one's that undefined, so we can't do anything to it. In fact, we'll just write right on it, undefined. And that'll just have to be it for that one. Okay, for this one right here, if we look left to right, this one is a negative, so I'm gonna box. Oh my gosh, I'm sorry, my box is, this just looks awful. All right, and then what about this one right here? If we look from left to right, it is a negative as well, so we're gonna box the negative. And then right here, if we look left to right, that one is positive. Oops. Oh. Sorry, it's difficult to do this with one hand. All right, and that is the slide. So if I have anything else to show y'all for the other paper, I will do so on another video. Thank you.